before the stars were born, before the galaxies spun in their graceful spirals, before even the faintest flicker of light illuminated the darkness, there was something, or perhaps nothing at all. We live in a universe defined by time. Time shapes everything we know: the fall of rain, the bloom of flowers, the rise and fall of civilizations. It drips slowly in quiet solitude and rushes past us when we are not looking. We measure it in seconds, in centuries, in cosmic eons. And yet, for all our familiarity with it, we know astonishingly little about where time comes from or what existed before it. The question is deceptively simple. What came before the universe? To even ask that question is to assume there was a time before time. But what does that really mean? According to our best scientific understanding, the universe began approximately 13.8 billion years ago with an event we now call the Big Bang. But contrary to popular imagination, it wasn't an explosion in space. It was the sudden appearance, the rapid expansion of space itself. Space and time. The very fabric of reality unfolding from a state of unimaginable density, from a singularity, a point where all known physics break down. So, if time itself began with the Big Bang, then what does before even mean? This question is not merely a philosophical curiosity, it is a boundary, a limit, a horizon beyond which our most powerful equations, our most elaborate theories, and our most daring speculations begin to unravel. A frontier where science and philosophy meet, and where both begin to falter. But still, we ask, because we must. For as long as humans have looked up at the night sky, we have wondered where we came from and what lies beyond. Ancient myths, sacred stories, and philosophical treatises have tried to answer the question in many forms. In the beginning, said one tradition, there was darkness upon the face of the deep. In another, the universe was born from a cosmic egg. Still others imagine cycles of creation and destruction, where time itself is not a line but a loop, repeating forever. Yet now, we have more than stories. We have telescopes that can see galaxies billions of light years away looking back in time. We have particle accelerators that smash atoms apart to reveal the substructure of reality. We have mathematics elegant and abstract that lets us peer closer to the moment of creation than any civilization before us. But not all the way. The Big Bang is still a wall we cannot pass. Time breaks down at that boundary. Space loses its shape. Gravity and quantum mechanics, our two great pillars of understanding, refuse to reconcile. Our equations reach infinity, and then nothing. Still, the question lingers. If time began at the Big Bang, could there be something that transcends time? Could there have been something else outside the framework we call reality? Could nothing be more than nothing? The idea is unsettling and exhilarating. Some physicists suggest that the Big Bang was not the beginning at all, that it was a transition, a phase change, like ice melting into water. In this view, the singularity wasn't a birth, but about the end of one universe and the start of another. The cosmos contracts, collapses into a dense state, then rebounds in a new expansion. A cosmic heartbeat, a cycle with no true beginning, only transformations. Others imagine a quantum vacuum, a seething, frothing field of energy, even in the absence of matter or space. In quantum theory, even nothing is unstable. Virtual particles pop in and out of existence in an eternal dance. Perhaps, from such a vacuum, a fluctuation large enough, occurred a momentary imbalance and a universe was born. Not created by a god or a will, but by probability, by chance, a roll of the cosmic dice. Still others invoke the multiverse, an infinite sea of bubble universes, each born from their own Big Bang, each with its own physical laws. In that view, our universe is just one among countless others, floating in a higher dimensional space, a foam of realities. In this grand tapestry, perhaps there was always something. Perhaps universes are constantly forming and dissolving, each unaware of the others. But if these things are true, if time is just one property of our universe, and not a universal feature of all that exists, then what is time, really? And more profoundly, what are we? Are we simply passengers riding a wave of space-time, unable to step outside the river to glimpse its source? Or are we, in some way, connected to the deeper truths echoes of a timeless reality glimpsed through intuition, art, and wonder? To ask what came before the universe is to stare into the heart of the unknown. It is to challenge the limits of language, of reason, and of perception, because even the idea of before implies the existence of time. And if time itself had a beginning, then the question may be inherently meaningless. And yet, we keep asking. Because the question is not just about physics. It's about existence. It's about meaning. It's about whether the universe had to be this way or whether it could have been nothing at all. Perhaps, in the end, that's what makes this question so powerful. Not because it will lead us to a final answer, but because it reveals the contours of our imagination. It forces us to confront the boundaries of knowledge and the breathtaking mystery that lies just beyond. The journey has only begun. Let us imagine, just for a moment, that the Big Bang was not the beginning, not a singular, miraculous instant of creation, but merely a transition, a doorway. There is a theory that has quietly endured since the early 20th century, gathering momentum with every unanswered question at the edge of cosmology. It is the idea that the universe has no beginning and no end, that it pulses. In this vision, the cosmos is a breathing entity. It expands as ours does now, cooling and thinning. But eventually, gravity slows its reach, halts it, and begins to draw it all back in. Stars fade, galaxies collide and collapse, and all of existence is crushed back into a single dense point, a mirror of the Big Bang, but in reverse. Then, somehow, it begins again. This is the cyclic uni. And if this theory holds, then the question, what came before the universe, is transformed. There is no before, only the last cycle, and the one before that, and the one before that. Time, in this model, may be infinite, but the arrow of time, the sense of moving from past to future, might be an illusion, or a localized phenomenon. The ancient Hindu cosmology speaks of vast cycles of creation and destruction, spanning billions of years, not so different from what modern cosmology hints at with different tools, different metaphors. Perhaps the deep intuitions of myth and the equations of theoretical physics are not so far apart. And yet, there is a problem. Our universe appears to be accelerating, not slowing. The galaxies are not just drifting apart, they are rushing away from one another, faster and faster, driven by something we still do not understand: dark energy. This mysterious force, responsible for nearly 70% of the energy in the universe, seems to ensure that the cosmos will expand forever cold, empty, and dark. There may be no collapse to trigger a new cycle. But nature, as always, is more subtle. Some modern versions of the cyclic model suggest that even in an ever-expanding universe, cycles can still occur not through collapse, but through changes in the structure of space itself. Imagine brains' vast, multi-dimensional sheets in a higher dimensional space. Two such brains collide, release energy, and a universe is born. They drift apart, and then, after untold ages, they drift back, collide again, and birth another cosmos. This is the Ekpyrotic universe, born not from a bang, but from a bounce between dimensions. In this view, our universe is not the only one. It is just the latest note in an eternal symphony of creation and renewal. But not everyone is satisfied with cycles. There is another idea, stranger still, yet rooted in the bedrock of quantum theory. It begins not with brains or gravity or even time. It begins with nothing. Or at least, what we used to call nothing. In classical thought, nothingness was a perfect void, empty, silent, dead. But quantum physics shattered that simplicity. In the quantum realm, even empty space is restless. Virtual particles flicker in and out of existence. Energy fluctuates in strange, unpredictable ways. A vacuum, far from being empty, becomes a seething sea of potential, a latent storm waiting to erupt. And from that storm, perhaps, a universe is born. This is the essence of quantum creation. In this model, a small patch of vacuum governed by the strange rules of quantum field theory can spontaneously fluctuate into a state of high energy. If that patch expands rapidly enough, its inflation can give birth to a whole universe with time, space, matter, and energy unfolding from that tiny seed. It may sound improbable, but it is not impossible. In fact, some versions of inflationary theory, the leading explanation for the early rapid expansion of our universe, suggest that quantum fluctuations not only can, but must create new universes all the time. Each fluctuation gives rise to a new bubble, a pocket universe with its own laws of physics. Some die immediately. Others, like ours, stabilize and flourish. This leads us into perhaps the most dizzying idea of all: the multiverse. If quantum fluctuations can create one universe, they can create countless. An infinite inflation, an endless foam of reality, bubbling with birth and death, with no beginning and no final end. Our universe, then, is just one bubble in a frothing, churning ocean, unremarkable, except to us. But if this is true, then the question changes once again. We no longer ask, what came before the universe? We must ask instead, what is the nature of the thing that creates universes? What laws govern the multiverse, if any? Is it eternal? Does it contain its own version of time? Or is it timeless and eternal now, from which all possible realities emerge? We do not know. We may never know, because if these other universes are truly disconnected from ours, if their space, their time, their particles are entirely separate, then their light will never reach us. Their evidence may be beyond all observation, but perhaps not beyond all imagination. Still, the idea is as terrifying as it is beautiful, because in an infinite multiverse, anything that can happen does happen. Every possibility is realized somewhere. There are universes where stars never form, where physics is unstable, where life is impossible. And also, universes where you never existed. Universes where you did, but different. And perhaps, just perhaps, universes where the question, what came before the universe, was never asked, because the beings there already knew the answer, or had long since stopped needing to ask. What if time isn't what we think it is? What if this thing we use to structure our days, to remember our past, and to imagine our future is not fundamental to reality at all? We speak of time as if it were a river, a current that carries us from birth to death, from star formation to galactic decay. We feel it move, we measure it, we depend on it. But is it real? Or is it an illusion, a trick, played on us by our biology, by our consciousness? In physics, time is not treated the same way in every theory. In Newtonian mechanics, time was absolute the same for everyone, everywhere. An invisible clock that ticked uniformly throughout the cosmos. Simple, intuitive, comfortable. But Einstein shattered that view. In his theory of relativity, time became entangled with space. Time was no longer absolute. It bent, stretched, slowed, and warped depending on how fast you were moving, or how deep you were in a gravitational field. There is no single now in Einstein's universe, no universal present. Two observers can disagree on the order of events, and both can be right. Time, in this view, is just another dimension like width, height, and depth. And just as we can look at an object from different angles, time, too, can be viewed differently depending on our motion and position. But relativity, elegant as it is, still treats time as real. What if it's not? Some physicists and philosophers suggest that time may not exist in any objective sense, that it is not woven into the fabric of the universe, but stitched into our minds. In the equations of quantum mechanics, time plays a strange role. In many cases, the fundamental equations that describe the state of particles don't change with time at all. They're static, timeless, as if the entire universe is frozen in a single, vast mathematical moment. In the Wheeler-DeWitt equation, an attempt to combine quantum mechanics with general relativity, time vanishes altogether. There is no T in the formula. The universe, as described by that equation, simply is. And that leads to a wild, unsettling idea. Maybe time is something we invent, not something we discover. A way for our limited minds to make sense of a universe that, in its deepest layer, does not unfold but simply exists all at once. This is called the block universe. In it, the past, present, and future all coexist. All moments are equally real. You as a baby and you as an old person are both there, not one after the other but side by side, like frames in a film reel. We are simply experiencing one frame at a time, giving the illusion of motion. In this model, before the universe is meaningless because all of time exists simultaneously. The Big Bang didn't happen before something. It is just one point in the block, a location in a timeless landscape. And yet, we feel time. We remember. We age. We act, plan, hope. So where does that sensation come from? Some scientists suggest that time is an emergent property, something that arises only in complex systems, like consciousness. In this view, time is not part of the universe until minds evolve to perceive it. The human brain is a pattern recognition machine. It links causes to effects, remembers sequences, and creates narratives. It builds order from chaos. And in that process, it constructs the illusion of flow of a past that is fixed, a present that is vanishing, and a future that is undefined. In this sense, time is a story, a useful fiction, a necessary illusion that allows us to survive, to make decisions, to live. But if time is an illusion, then so is the question, what came before? Because before assumes a timeline, a sequence. Without time, there is no before, no after, no progression at all. It is like asking, what's north of the North Pole? The question breaks down because it assumes a frame of reference that ceases to exist at the very point it is applied to. And yet, something about that is deeply unsatisfying. We are creatures of time. We cannot help but think in its terms. Even when we try to step outside it, we do so in time. We are trapped. Or perhaps we are just young. Perhaps, in some distant future, a new form of intelligence, artificial, biological, or something in between, will develop a different way of perceiving reality, one that does not require time, one that can grasp the universe as it truly is, not as a sequence, but as a structure, not as a journey, but as a state. Such a mind might see the Big Bang not as a beginning, but as a feature in a timeless whole. It might understand the fabric of existence in a way we cannot yet imagine. It might laugh at our questions or weep at our longing. Until then, we ask, what was before the beginning? Was there a cause, a purpose, a moment, a flicker? Or was there only stillness, perfect, endless stillness? And in that stillness, the potential for everything. We speak of nothingness as if it were simple. We say, there was nothing before, or out of nothing came everything, as if the word nothing were clear, sharp, and final. But nothingness is perhaps the most misunderstood concept in all of thought, because the more we examine it, the closer we get to it, the more it slips through our fingers, revealing layer after layer of paradox. What do we mean when we say nothing? Is it a place? An absence? A vacuum? A void? In ancient times, nothingness was terrifying. To imagine a state where there was no air, no ground, no stars, not even gods, it was to brush against non-existence itself. Many early philosophies and religions rejected the very idea that true nothingness could exist, something they believed must always have been. But science, especially modern physics, invites us to look more closely. In classical physics, a vacuum is the absence of matter, empty space, a box with all the air sucked out, a perfect void. And yet, even that box is something. It has dimensions. It has boundaries. It exists in space and time. In quantum physics, the void becomes even more elusive. What we call empty space is in fact boiling with activity. Quantum fields fill all of space, and even in their lowest energy states, the vacuum states, they do not rest. Instead, they fluctuate. They ripple. They buzz with virtual particles that appear and vanish in instants. These fluctuations are not theoretical, they have been measured. They exert forces. They leave traces. So even when we think we've stripped the universe down to nothing, something remains. This leads to a stunning conclusion. Perhaps nothingness has never existed. Not even for a moment. Even before the Big Bang, even in that hypothetical silence that preceded everything, there may have been something, a quantum field, a law, a boundary condition, or perhaps a possibility, a landscape of potential realities waiting to be realized. And that raises a deeper question. If nothing is unstable, if nothing naturally gives rise to something, then is nothing really nothing? Or is it simply the canvas on which existence paints itself? The philosopher Heidegger once asked, why is there something rather than nothing? It's one of the oldest, most haunting questions, and perhaps the most unanswerable. But some physicists believe the answer might be found in mathematics, in the strange behavior of quantum mechanics, in the idea that fluctuations in the vacuum can, with some probability, trigger the emergence of a universe. A bubble inflates, time and space erupt from it, particles form, stars ignite, and the story begins. This isn't a miracle in the traditional sense. It is the logical consequence of the laws of physics, or, more precisely, of the potential for laws to emerge within structured patterns. But that too invites another question. Where did the laws come from? Where did the framework that allows quantum fluctuations or space or dimensions or logic originate? Can laws exist without a universe? Can mathematics be real without a mind to think it? We begin to see that the idea of nothing is not the bottom of the well. It is a door behind which lie other doors, endlessly receding. And perhaps, at the base of everything, is not matter, or energy, or fields, but information. Some scientists and philosophers suggest that the universe itself is a computational structure. That everything we experience arises from the manipulation of bits, yes, no decisions, zeros and ones, logic gates deeper than physics. In this view, the laws of nature are not discovered but executed, like lines of code. And the initial condition, the nothing, before the universe may simply have been a null state, ready to be switched on. But if the universe is computation, what is the computer? Who or what runs it? And again, we fall into an ancient trap. Because even as we try to remove gods and creation myths, we find ourselves slipping back into metaphors, machines, minds, logic that serve the same narrative purpose. We want an origin. We crave a cause. We are addicted to beginnings. And maybe that's our flaw. Because if time doesn't exist outside the universe, then neither does causality, the idea that one thing follows another. The nothing before the Big Bang may not have caused anything. There may not have been a before. There may only be a boundary like the surface of a sphere, with no edge, no outside. Some cosmologists even suggest that the universe didn't emerge into time, but with time. That asking what happened before is like asking what's south of the South Pole. There is no direction. The question dissolves. And yet, in our deepest longing, we continue to reach for the void. We yearn to look into that perfect emptiness, to touch the silence that came before the first heartbeat of reality. Perhaps we are not looking for nothingness at all. Perhaps we are searching for origin, not in the physical sense, but in the emotional one. A beginning, a home. Because in every myth, in every theory, in every equation and story and thought experiment, what we are really searching for is this. Where did we come from? What are we made of? And why is there anything at all, rather than an eternal, impenetrable silence? Maybe, just maybe, that silence was never there to begin with. What if the universe does not truly exist until it is observed? This sounds like philosophy, ancient, circular, untestable, but it is also quantum physics, and it is very real. In the early 20th century, as physicists began to explore the strange rules of the subatomic world, they encountered something deeply unsettling. At the smallest scales of reality, particles didn't behave like solid, objective things. They existed in clouds of probability in overlapping states until someone or something observed them. Only then did they snap into a definite state. This is known as the observer effect. And at its core lies a profound question. Does observation create reality? In the famous double-slit experiment, a single particle is fired at a barrier with two slits. Behind the slits is a screen to record where the particle lands. If no one observes which slit the particle goes through, it behaves like a wave interfering with itself, forming a pattern of ripples. But if we try to measure which slit it passes through, it no longer behaves like a wave. It behaves like a particle. The act of observation, even by a machine, changes the outcome. Why? What is so special about looking? Some interpretations suggest it's not consciousness that matters, but information. The moment information about the system exists, even if no one reads it, the quantum system collapses into a specific state. But others are not so sure. Some physicists have speculated that consciousness itself plays a fundamental role in shaping reality, that it is not a product of the universe, but a partner in its creation. In this view, the universe may not have simply exploded into being on its own. It may require a witness, a mind, to bring its possibilities into actuality. If that is true, then we arrive at a staggering reversal. We do not live in the universe. The universe lives in us. It's an idea echoed in ancient spiritual traditions, that the world arises in awareness, that the obs. But even if we put aside such metaphysical interpretations, we are still left with something just as haunting. Without an observer, what does it mean for something to exist? If a tree falls in a forest, and no one is there to hear it, does it make a sound? If a universe is born, and no consciousness ever arises within it, no awareness to marvel at galaxies, no intelligence to ask questions, did it ever really happen? The emergence of consciousness in our universe is, by all accounts, an extraordinary thing. For billions of years, there was no awareness, no thought, no concept of time or meaning or truth. Then, slowly, through the intricate dance of chemistry and physics, a new phenomenon emerged: minds. Beings that could reflect, beings that could imagine, beings that could suffer and love and wonder. It is tempting to think of consciousness as a side effect, an accident, a fluke. But what if it is central? What if consciousness is not the last step in cosmic evolution, but the first clue to its purpose? The physicist John Archibald Wheeler once proposed the idea of the participatory universe, that consciousness and the cosmos are locked in a mutual relationship, that the universe brings forth observers, and those observers bring forth the universe. He wrote, "No phenomenon is a real phenomenon until it is an observed phenomenon." This is not to say that we create stars by looking at them, but rather that reality as we know it may only crystallize into definiteness through observation. And in a universe with no observers, there may be no events at all. No past, no future, no time. Only uncollapsed possibilities. And so, once again, we find the question twisting back on itself. If the Big Bang gave rise to space and time and energy, did it also give rise to consciousness? Or did consciousness, in some strange, outside sense, give rise to the Big Bang? This sounds mystical, unscientific. But the edges of physics are filled with such questions. Questions that mathematics alone cannot resolve. Because we are not outside observers of the universe. We are inside it, made of it. We are star stuff contemplating star stuff. Quantum fields reflecting on themselves. time-bound creatures asking about what came before time. Perhaps that is why the question feels so impossibly large, because the one asking it is also the thing it seeks to understand. And yet, we continue. We observe. We measure. We build machines to see farther and deeper. We send messages into space, hoping someone, something might respond. Not just to confirm we are not alone, but to validate that we are real. Because in the vast silence of the cosmos, what gives meaning to existence is not just that it exists, but that it is known. What are the limits of what we can know? It's a question that haunts the deepest halls of science, and one that grows louder the closer we get to the edges of reality. We often speak as if the universe is an open book, and our task is simply to turn the pages fast enough. That if we build better telescopes, bigger particle colliders, more powerful simulations, the whole story will eventually reveal itself, all the way to the beginning, all the way to the source. But what if some pages are sealed? What if some sentences are smudged beyond recognition? What if the final chapter can never be read not because of a lack of effort, but because of the fundamental rules of the story itself? To understand why, we must first recognize a simple but profound truth. Knowledge has boundaries. Physics is not just a description of how things behave, it's also a map of where our knowledge must end. And there are at least three kinds of limits we face: the observational, the computational, and the logical. First, the observational. We live in an expanding universe, and that expansion means there are parts of the cosmos we can never reach, not in theory, not in practice, not even in principle. The speed of light, though unimaginably fast, is still finite, and as space stretches, distant galaxies are being pulled away from us faster than their light can travel. That means there are galaxies, billions of them, whose light will never reach us. Entire realms of existence beyond our cosmic horizon. They may be out there now, teeming with stars and worlds and wonders. But they are, and will forever remain, invisible. For us, they are as good as non-existent. And it gets worse. Because of the universe's accelerating expansion, even galaxies we can see today will one day drift out of reach. Their light will stretch into radio silence. Eventually, only a small local patch, our own group of galaxies, will remain visible. The rest of the universe will fade, not because it dies, but because it escapes. We are surrounded by an ocean that is receding not just spatially, but informationally. There are things we will simply never know. Not because we're not clever enough, but because nature won't let us. Second, the computational. Our brains are remarkable, the most complex known structure in the universe. But they are still finite. We have roughly 100 billion neurons, connected by about 100 trillion synapses. Our conscious mind can process about 40 bits of information per second. That's enough to survive, enough to dream, enough to ask questions. But it is not enough to contain the universe. Even our most advanced supercomputers, built from millions of processors and operating at billions of instructions per second, are dwarfed by the information embedded in a single star, let alone an entire galaxy, or the entire cosmos. And if the universe contains not just particles and fields, but information quantum states, entangled systems, emergent properties, then to fully describe it would require more storage than any system could hold, even in theory. Imagine trying to record every particle, every interaction, every potential state in the observable universe. There are roughly 10 circumflex 80 protons, each with location, momentum, spin, quantum phase, and those are just the knowns. The configuration space, the possible arrangements, is far, far larger. It is, quite simply, too much. There are questions that cannot be answered, not because they're meaningless, but because we don't have enough room to write the answers down. Then, finally, the logical limits. In the 1930s, mathematician Kurt Gödel proved something astonishing. Any system of logic, any formal structure capable of expressing arithmetic, is inherently incomplete. There will always be truths that are true but cannot be proven within the system. And if you try to build a bigger system to capture those truths, the new system will also have unprovable truths of its own. This is known as Gödel's incompleteness theorem, and it shook the foundations of mathematics and philosophy alike. What it means for cosmology is chilling. Even if we had a perfect theory of everything, a final equation, elegant and complete, there may still be aspects of the universe it cannot describe, questions it cannot answer, paradoxes it cannot resolve. And so, from the outer edges of observation, to the finite limits of memory, to the deep logic of reality itself, we are faced with a wall, a limit, an end not of the universe, but of comprehension. But maybe that's the point. Maybe the goal of understanding was never to conquer the cosmos, to bottle it, label it, file it away. Maybe the real goal was to feel its depth, to be humbled by its vastness, to stand at the edge of the known and gaze into the unknown and be filled, not with despair, but with awe. Because if there is a boundary to knowledge, then what lies beyond is not darkness. It is mystery. It is wonder. It is the infinite invitation to keep asking, even if the answers never come. Why is there something rather than nothing? It may be the most fundamental question ever asked, and perhaps the most impossible to answer. We take existence for granted. We wake up, breathe air, see the sky, feel gravity tugging at our bones. The world is here. We are in it. But must it have been this way? Could there have been nothing? No space, no time, no matter, no laws, no consciousness, not even a void, just the total, absolute absence of everything. Try to imagine that. Not blackness, not stillness, not even emptiness, but non-existence. Not a blank page, but no page at all. Not a pause, but no concept of motion, or stasis, or thought. A nothing so pure that even the idea of nothingness has no place. And yet that's not what we find. We find a universe. We find galaxies, stars, atoms, oceans, minds. We find something. So the question becomes, was that something necessary or contingent? If the universe had to exist, if its existence is built into the structure of logic itself, then the mystery. But if the universe could have not existed, if true nothingness was possible, then we must ask, why did it not remain that way? Was there a cause? Was there a mechanism? Was there a decision? And if so, who or what made it? Science, for all its power, is not well equipped to handle these questions. Because science is built on contingency. It explains how things evolve from prior states. It maps change. It describes what happens next. But when we ask about why anything exists at all, why there was ever a first state, we step outside the domain of causes. We reach into pure metaphysics. Some thinkers suggest that the universe may be a brute fact. It just is. There is no reason, no origin, no deeper explanation. The cosmos, in this view, is not a question. It is an answerless presence, an isness. Others propose the principle of fecundity, the idea that everything that can exist must exist, that all possible realities are real, somewhere, somehow. In this view, our universe is just one expression of possibility. The fact that we are here is not special. It is simply one node in a boundless tree of branching outcomes. This sounds like the multiverse again, and in some versions, it is. But there are deeper, stranger ideas. Some physicists argue that the laws of nature are not fixed, that they too evolve. Just as biological systems adapt through variation and selection, perhaps cosmic evolution favors universes that are stable, long-lived, and capable of generating complexity. In this picture, universes might reproduce through black holes or other mechanisms, spawning offspring with slightly altered physical constants. Over time, only the most fruitful universes survive. It's speculative, yes, but it offers a kind of Darwinian logic to cosmology, a natural selection of existence itself. Still, none of these theories answer the central riddle. Why is there something instead of nothing? Could it be that nothing is unstable? That the total absence of being is, paradoxically, unsustainable, and so, inevitably, something arises? This is the suggestion of quantum cosmology, that fluctuations in the vacuum, the ground state of all fields, are enough to nudge the universe into being. But again, this assumes laws, fields, probabilities. It assumes a backdrop on which fluctuations occur. Where did that come from? And again, we find ourselves turning in circles. Each explanation invites a deeper one. Each why births another. Some suggest that the ultimate answer lies not in physics, but in mathematics. Perhaps the universe exists because mathematics exists. And not just as a tool of description, but as the fundamental substance of reality. In this view, what we call the universe is simply the unfolding of a mathematical structure, timeless, eternal, inevitable. It was not created. It simply is. If true, then the question, why is there something, is replaced by a new one. Why does mathematics exist? And that, too, may have no answer. Or perhaps the problem is with us. Perhaps the question itself is flawed. Perhaps we are trying to apply human logic, linear, causal, finite, to a reality that is infinite, non-local, and beyond comprehension. We want a reason. We want a story. But reality may be before stories, before minds, before cause. It may just be. And maybe that is enough. Maybe the deepest wisdom is to sit with the mystery, to hold it gently, to allow it to remain open, not as a failure of understanding, but as an invitation to humility. Because sometimes the greatest act of knowledge is to know that we do not know. Infinity. Few words carry more weight, more contradiction, more quiet terror. It is the idea that something has no end, no boundary, no final step, no last breath. We often think of the infinite as a kind of backdrop, the canvas on which space stretches, where time rolls endlessly forward. But when we actually try to grasp it, it slips from our understanding. Because infinity is not just big, it is not just long, it is beyond. Our minds were not built for it. We evolved to throw spears, build shelters, survive seasons. We are finite creatures trying to comprehend the uncontainable. And yet, infinity surrounds us. Look at the stars. The observable universe is vast, about 93 billion light-years across. But that's just the part we can see. Beyond it may lie regions we will never observe, expanding faster than light can travel, teeming with matter we will never touch. Is the universe infinite in size? We don't know. It might curve back on itself, like the surface of a sphere. Or it might extend forever flat, featureless, unbounded. Then there's time. If the universe continues expanding, driven by dark energy, it may go on forever. Stars will fade, galaxies will thin out, matter will decay, but space will remain. A cold, dark ocean stretching endlessly into nothingness. Is time infinite? Again, we don't know. It may end in a heat death, a state of maximum entropy where no structure, no memory, no life can exist. A stillness that is not peace, but exhaustion. But then, there is mathematical infinity. In the late 1800s, mathematician Georg Cantor made a discovery so strange that even his peers doubted his sanity. He showed that there are not just one, but many sizes of infinity. There's the countable infinite, like the set of natural numbers, and the uncountable, like the real numbers between 0 and 1. Both are infinite, but one is more infinite than the other. This idea shook the foundations of mathematics, and it raised a question far deeper than it first appeared. If the infinite can come in degrees, then what is its nature? What is its structure? Today, we use infinity in physics all the time to describe limits, ideal cases, singularities, but we rarely ask what it means, because to stare too long into the infinite is to risk losing our grounding. Still, some theories demand it. In quantum mechanics, the number of possible configurations of particles in the universe is unimaginably large, perhaps infinite. In cosmology, eternal inflation suggests that new universes are being spawned endlessly, each with different physical constants. In mathematics, the space of all possible functions, shapes, and truths is infinite in every direction. And so we ask, if infinity is real, if existence is infinite in scope, what does that mean for us? One consequence is repetition. In an infinite space with a finite number of arrangements, patterns must repeat. There will be places where everything is exactly as it is here, same Earth, same history, same you. And there will be places where one detail differs. Places where the dinosaurs never died, where World War II never ended, where you made a different choice, said something else, became someone else. In a truly infinite multiverse, everything that can happen does happen. Not once, but endlessly. This is not fantasy, it is mathematics. And it forces us to reconsider what it means to be real. Are you the original? Are there originals? Does that even matter? Then there's the infinite regress of explanation. For every cause, we ask, what caused that? For every universe, we ask, what birthed it? And for every law of nature, we ask, why this law and not another? In a finite world, such questions might end. But in an infinite one, they never do. Each answer gives birth to a new question. Each discovery opens another door. Each beginning hides another before. Infinity turns knowledge into a spiral. We ascend, we deepen, we illuminate, but we never arrive. And maybe that's the point. Maybe the purpose of intelligence is not to solve infinity, but to be in relationship with it, to dance with it, to be humbled by it. Because infinity means there will always be more to learn, more to create, more to ask, more to become. We often think of limits as boundaries, as walls that keep us in. But perhaps the infinite is the opposite of a limit. It is not a wall, but a mirror. It reflects our questions back at us endlessly, until we realize that the answers we seek may never come, but the act of seeking is the answer. And so, when we ask, what came before the universe? Maybe we are not looking for a moment in time. Maybe we are glimpsing an edge of infinity. And if so, it is not a place to fear. It is a place to wonder. Could something or someone have planned the beginning? It's a question that has echoed through temples and laboratories alike. The idea that behind the complexity of existence, behind the elegant equations and delicate balances, there might lie a mind not human, but something far older, stranger, and more profound. It's not a new question. In fact, it may be the oldest. When early humans saw lightning split the sky or stars trace patterns overhead, they imagined beings behind them, gods who wove the heavens, spirits who stirred the oceans. Today, we ask it differently. We speak of fine-tuning, of initial conditions, of constant set just so. And we wonder, did it all have to be this way? Could the universe be the result of design? Let's be clear. This is not a question of religion or doctrine or myth. This is a question about information, about structure, about intention. Because the more we study the universe, the more finely calibrated it seems. The strength of gravity, the mass of the electron, the cosmological constant. These numbers appear arbitrary, and yet if they were just slightly different, atoms wouldn't form, stars wouldn't ignite, life would never emerge. Some scientists argue this is a selection bias. We see a universe that permits life because we are here to see it. If it were different, we wouldn't be here asking the question. This is the anthropic principle, tautological, but not necessarily wrong. Others go further. They suggest that if many universes exist, each with different constants, then of course one of them would look like ours. We just happen to live in the lucky one. But there are those who entertain another possibility. That the universe's order is not just a coincidence, but a signal. If there was a designer, what kind of intelligence would it require? Not a being with hands and eyes, not a figure on a throne or in the clouds, but something more like a mathematical mind, a cosmic architect, capable of setting the initial conditions for an entire reality. Perhaps not even a consciousness in the way we understand it. Perhaps a meta-consciousness, an intelligence that operates across time or outside of it altogether. If such a being exists, what would it be like? Maybe it's an advanced civilization, one that achieved mastery over physics so complete that it could simulate or construct universes from scratch. We call this the simulation hypothesis, the idea that our universe is a kind of program, running on a substrate we cannot see. If so, the beginning of time was a boot-up moment. The Big Bang was a line of code executing, and everything since space, stars, evolution, thought has unfolded within a system designed for reasons we cannot yet grasp. But even this leads to recursion. If we were simulated by another intelligence, then who created them? And who created that? We are back at infinite regress. Still, there are those who believe that intelligence is not a byproduct of the universe, but a principle of its evolution. That consciousness, self-awareness, is the endpoint toward which complexity moves. That the universe is not just physical, but teleological, directed towards something. This is not a belief in a person or a deity. It is a recognition of pattern, a trajectory from simplicity to order, from chaos to consciousness, from hydrogen to humans, and perhaps beyond. What if intelligence is not local, but cosmic? What if the universe is learning about itself through us? Or more radically, what if intelligence was already there at the beginning? Not watching, not intervening, but simply being. Not a creator outside the system, but a presence within it encoded into the structure of space-time itself. Some theories of quantum gravity suggest that information is the most fundamental building block of reality. Not particles, not energy, but bits. If true, then intelligence might not be something that emerges from matter, but something that is matter, arranged in certain ways. And if intelligence is embedded in the universe, then perhaps it can be awakened. Perhaps the cosmos is not dead and indifferent, but potentially conscious, waiting for parts of itself to reflect, to wonder, to reach back across time and ask, who made this? And in that moment of asking, the loop closes. The observer becomes the observed. The thought becomes the thinker. We may never find evidence of a designer. We may never detect a signal or meet a cosmic mind. But perhaps the greatest design of all is the fact that we can even ask the question. Because to ask who made the universe is not just a scientific inquiry. It is a mirror. And in that mirror, we glimpse not an answer, but ourselves. We began with a question. A simple one. At first glance, childlike, even. What came before the universe? But like all great questions, it was a key. A key that opened not just doors to knowledge, but to wonder, to uncertainty, to the deep stillness that lives between thoughts. And now, at the end of our journey after cycles and singularities, quantum voids and infinite regress, we arrive not at a final answer, but at a kind of stillness. Perhaps that's how it has to be. We've seen how time, as we know it, may be an emergent property, not fundamental, not absolute. That before the Big Bang, there may have been nothing, or something, or a state so alien that human language collapses in its presence. We've explored models where the universe is cyclic, bouncing forever, where universes butt off one another like bubbles in an eternal froth. We've encountered the notion that even nothing is unstable, that from vacuum, structure can emerge, that the universe is not born from absence, but from the restless potential of existence itself. And still, we ask. We've peered into the limits of knowledge, found that some truths may lie forever beyond our horizon, sealed away not by ignorance but by physics itself. We've seen that the infinite may not just be long, it may be recursive, reflective, inescapable. That even intelligence, consciousness, may not be latecomers to the party, but part of the very architecture, the quiet engine behind the curtain. And yet, despite all this exploration, one truth remains. We do not know. We may never know. But maybe that's not a failure. Maybe it's a feature. Maybe existence isn't a puzzle with a solution, but a mystery to be lived. Because in mystery, something extraordinary happens. We are reminded of our place, not as conquerors of the cosmos, not as masters of equations, but as participants in a story that is far older and deeper than we can imagine. We are reminded of the silence between the stars, of the questions whispered at night, when the noise of the world falls away. We are reminded that we are finite and yet capable of imagining the infinite. And that is no small thing, because the greatest miracle may not be the Big Bang, or the laws of physics, or even the existence of galaxies and minds. The greatest miracle may be this: that we, fragile, momentary, mortal, can ask what came before time and care about the answer. That we build telescopes not just to see, but to understand. That we craft theories not just to predict, but to wonder. That we look backward across 14 billion years and still hunger to go further. In that hunger, we become something more. Not just products of the universe, but reflections of it, witnesses, awakened atoms, dreaming of origin. So perhaps the question is not, what came before the universe? But rather, what are we becoming in asking that question? And if time truly began with the Big Bang, if there is no before in any meaningful sense, then this, here, now, is the first moment. Always, and always again.